right, so here's our first notes on our stoichiometry. So we've already gone through what a mole is, learn to calculate molar mass, and remember those coefficients in the front, those are the number of moles of the molecule. So we're going to use those in our notes today as we learn how to go from a mole to a mole. And it's going to be the same idea as those basic conversion notes that we did and worksheet. Okay, and so we're going to use the same kind of idea with that dimensional analysis to learn how to do mole to mole. And so it's under Unit 8 Stoichiometry, and there's your Google Doc to take your Cornell notes on. And then make sure to add highlights and a 3 to 5 sentence summary of your notes before submitting. And also make sure that you turn it in. All right, so let's go ahead and get started. All right, so this is stoichiometry. This is our math and chemistry, and our first step, which is what we call our one step, is what we call from moles to moles. So moles of one substance to the moles of another one. So our central question here is, how do we convert moles? How do you convert moles of a substance to moles of another substance? All right, so let's go ahead and get started. All right, so if you want to read up a little bit more in your chemistry book on page 359, writing and using mole ratios, mole to mole calculations, and there's even a sample problem I want you to stay with, 12.2. So you can do some reading, extra reading in your chemistry book if you need it. All right, a little definition. So remember we talked about a mole, and it equals Avogadro's number, that's 6.02 times 10 to the 23rd. And it is the coefficient in a chemical reaction, such as you see here. So these are our coefficients, those numbers in the front, the way we balanced our equations. And a mole ratio is the conversion factor created from the coefficients of a balanced equation. And I'll show you how to do that and create that mole ratio here today. All right. So how to create a mole ratio. So a mole ratio is created from the coefficients from a balanced reaction. So you have to balance the chemical reactions first. And you must balance it so that you know the ratio of so many molecules to another molecule. Remember when we talked about rates of reaction, we had to have so many molecules present to make that reaction begin, okay? And so a balanced reaction here, so this is our example. Here's our balanced reaction. And then what is the mole ratio for oxygen O2 to sulfur oxide? And it will always be written this way on your exams as well. We will give you the name and then also the molecular formula, okay? And so you can write it two different ways. Just like you were able to do that with the basic conversions, you could flip them back and forth. You can do the same thing with a mole ratio or any of the conversion factors that we create here in chemistry. So you could do 1 mole, because there's a 1 in front of oxygen, to 2 moles of sulfur oxide. Or you could have sulfur oxide on the top, have 2 moles of sulfur oxide to 1 mole of oxygen. You just have to have the 1 with the oxygen and the 2 with the sulfur oxide. And then how do we convert moles to moles? So we convert from moles of one molecule to moles of another molecule in a chemical reaction to determine the amount of each molecule we need to add to make the reaction occur. So when I set up all of these experiments for you guys in the classroom, I actually have to balance the equation, calculate how many moles of each one I'm going to need to mix them to make that reaction work, or you'd mix them together and nothing would happen. So our first example is making water. I need 2 moles of hydrogen plus 1 mole of oxygen to make 2 moles of water. You have to have 2 moles of hydrogen, here as it says, with 1 mole of oxygen, or it doesn't work, okay? And it says 1 mole of hydrogen. I'm going to fix that real quick. That's better. 2 moles of hydrogen and 1 mole of oxygen to make the reaction occur. And converting also helps us predict how much of a product will be produced. So we know exactly if I start with so many moles of hydrogen or oxygen, how much water am I going to make? And from the reaction, you can see that if I have 2 moles of hydrogen and 1 mole of oxygen, I will actually make 2 moles of water. Okay? All right. So let's look at example 1 in going from moles to moles. So here's our balanced equation. It's already balanced for you. And most of the time as we're doing these, we will balance them for you. If we start with 4 moles of oxygen, how many moles of water would be created. So we're going to start actually with 4. I know this says 3, but our given is 4, and that's always where we're going to start. We're always going to start with what is our given amount in our problem. So we could have the mole ratio of oxygen and water, because that is what it's asking for, oxygen to water. So we have 3 moles of oxygen, which is made, the mole ratio, remember, is made from our balance equation, to 2 moles of water, or we could have 2 moles of water on top and 3 moles of water oxygen on the bottom. Now we're going to convert 4 moles of oxygen to moles of water. So we're going to start with our given, which is 4 moles of oxygen times, and just like our conversion, remember, we always want what we have, or the units we have, on the bottom. So we have moles of oxygen, and we'll put that on the bottom, and what we want to figure out is moles of water. So that goes on the top. So we're going to use this conversion here, and we'll put 3 with oxygen, 2 with water, and what will happen is moles of oxygen will cancel with moles of oxygen to leave moles of water. And then you will read across. And remember, it doesn't matter, but I'll go 4 times 2 divided by 3. If you did 4 divided by 3 times 2, you'd get the same answer. And it should be 2.67 moles of water. So if I mix 4 moles of oxygen in there and I have a ton of the hydrogen sulfide, I will get 2.67 moles of water. All right, let's look at another example. So here's our balanced equation here. What if you start with 3 moles of nitrogen? How many moles of hydrogen do you need for the reaction to occur? So let's say you're starting the reaction, you're like, well, I only got 3 moles left. How many moles of hydrogen do I need to add to make sure I can make my ammonia? So you're going to first create the mole ratio between nitrogen and hydrogen, because that's in our question. And so there's 1 mole of nitrogen to 3 moles of hydrogen, or 3 moles of hydrogen to 1 mole of nitrogen. You could use either one. And then we're going to write, the first thing we're going to write is our given, which is 3 moles of nitrogen. Multiply, and on the bottom we're going to put the units we have, which is moles of nitrogen, and the units we want on top, which is moles of hydrogen. And then moles of nitrogen will cancel out because it's on the top and the bottom, and we're left with moles of hydrogen, which is what I want. And so I will go 3 times 3 divided by 1, or 3 divided by 1 times 3. And I should get 9 moles of hydrogen either way. Okay? All right, so that is mole to mole ratio. We'll practice that more in class on some on a Poggle, but go ahead and process your notes now. Highlight any important notes, make connections to any of your notes in the left-hand column. Write any questions you may have in the left-hand column. Use your highlights, connections, and questions for your summary. And then you're going to write a 3 to 5 sentence summary. If you have any questions, please let me know.